Alright, well, I think the recorder has started. Let me just double check and make sure. Alright, that's good. We have, first thing is I have to remind you guys that we have our first exam next Thursday. Okay, 1 week from this Thursday, we'll have our midterm 1. It is open book, open notes. Okay, anything that is either printed or handwritten prior to the test, you can bring it with you. Okay, you guys can work together, to come up with, basically notes that you want to bring it to the exam. That's okay. So any collaboration prior to the test is okay. Collaboration during the test is not okay. All right. Are there any questions about the exam? How to get ready for it? We'll have our practice exam on Thursday, so we'll go over some questions on Thursday as a practice. It does not count for any points, so you're not going to lose any points. In fact, there's nothing for you to turn in on Thursday. I'm just going to go over the questions on the whiteboard, on the projector. I will be asking new questions. I have some idea of new type of questions to ask compared to all the exams that I have had in the past. So it will be slightly different in some way, but it will still be asking about the same kind of concepts as all my other tests. All right. Any questions? Yep.
Sorry, when was the exam?
The exam is next Thursday, so
okay.
I think it's the 13th of March. And the same time, we'll start the exam at exactly 10:30, and it will conclude at exactly 11:50. So you have 80 minutes to work on your questions. All right. So the first thing I want to do is just kind of quickly go over the homework assignments that is due on this Thursday. The only reason why I schedule the exam 1 to be next Thursday is because it will have pre and post conditions, and I want to make sure that you guys have a chance to practice the pre and post condition question as a homework before we have that as an exam question. So we'll go ahead and take a look at your question here, and I want to see if there are any questions regarding how to do this homework assignment. So what you need to do is to kind of go back to the notes, the stuff that we talked about last Thursday, because on last Thursday, I specifically gave you the steps that you need to show in order to do this homework assignment. So I'm going to do with this class, what I did with the previous class, which is to go to YouTube and watch the video again. But not really just replaying the whole thing, okay? It's not just replaying the whole thing. I'm pretty sure you guys know how to do that already. But what I will do instead is I'm going to, and by the way, if you bump up the resolution to 720p,
You can actually read it.
well, it's actually pretty sharp. I mean, it's actually pretty decent when you bump up the resolution. And
When I looked at it the other day, it automatically set to 140p, and
that would not be
it was
helpful.
horrible. I didn't understand what was going on for about 3 seconds until I remembered that there was an auto setting.
You're recording on VHS.
A VHS recording.
All right, so what we'll do is I'm going to start with this part here, as YouTube trying to stream more stuff into it. And I'm pretty sure the district IT people are doing what they call throttling and say, well, YouTube stuff will give you the least bandwidth. We'll let you use the leftover bandwidth right here because you're not doing anything related to class. But I am doing something related to class. Okay, so we'll start with this part here. This is a template. Okay, this is basically a template to help you get started with your homework assignment, or every time you want to derive the post condition from a precondition of an assignment statement. This is how we get it started. The first part is this part here. I'm just generalizing and say this is line n in a particular algorithm, so this way I don't have to refer to a specific line. The left-hand side is really just whatever variable the assignment statement is about to change, and the right-hand side is the expression on the right-hand side, which specifies the value that you will be using in order to change the variable on the left-hand side. In other words, this is a very general template that is applicable to any assignment statement. Okay, you have a line number, you have a left-hand side, which is a variable, and you have a right-hand side, which can be any expression. All right, so we start with step 1. Step 1 says define the function f so that the independent variable of the function is the left-hand side variable, and then the definition itself is the expression on the right-hand side. Is that part okay? So step 1 is really just identifying, what is my left-hand side, what is my right-hand side, and I'm defining my function f accordingly. Is that okay? All right. Then we move on to step 2. Step 2 is the only part that can be a little bit tricky, which means you have to find out whether f has an inverse function or not, and if so, what is it? Is it reversible? Okay, that's the question. Generally speaking, if the expression on the right-hand side does not refer to the variable on the left-hand side, it is not reversible. Occasionally, you would have one where the right-hand side refers to the left-hand side, but it is still where it is still not reversible, like x minus x is always 0. So even though it is x minus x, it is still not reversible in that case. But those would be kind of like odd and kind of tricky cases. In this class, I'm not going to give you anything that involves sine, cosine, or something like that. It will all be adding 1, subtracting 1, dividing by 2, multiplying by 2, that sort of thing. Step 3a is what you apply when there is an inverse function. In other words, if you find an inverse function in step 2, then you have to apply step 3a. If you do not find an inverse function in step 2, then you have to apply step 3b, which is the forget operation. So are we still doing okay so far with these 3 steps, basically? Step 1, break it up into 2 parts, define function f. Step 2, find out whether function f has an inverse function or not. Step 3a says if there is an inverse function, apply the substitution operation. Step 3b says if there's no inverse function, then we use the forget operation. Okay? So these are the steps that you have to show me in your answer when you turn in your homework assignment. Yep.
So this is for every line that has an assignment statement?
Yep, for every line. You do not have to spell it out the same way as I do. You can basically make it more simplified and just say, f of blah 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 is this. It has an inverse function, and as a result, we apply this operation. So you can simplify a little bit, but all this information still has to be there. I have to know why you choose a substitution operation or why you choose a forget operation. All right, so now we have 3a1 spelled out and 3b1 spelled out here. 3a1 follows 3a, 3b1 follows 3b. Hoping that part is kind of obvious. Okay. So if you choose that, there is an inverse function, I want to apply the substitution operation, then the next step is 3a1. 3a1 is the template of how you apply the substitution operation. The substitution operation has 3 components. The first component, and by the way, substitution just means find and replace. It's the same thing as find and replace or search and replace depending on which word processor you use. The first component is what is the original one. Okay, what is the original precondition? The second component specifies what we are searching for, and the third component specifies what are we replacing it with. Okay, so those are the 3 components of the substitution operation. If there's no inverse function, you cannot apply the substitution operation. In that case, you have to apply a forget operation, which is represented by 3b1 here, and the forget operation has a template that looks like this. You have to apply the forget operation to the precondition. Any comparison that mentions the left-hand side, you have to basically remove that from the expression, from pre-n, the precondition of line n. After you forget the entire after you apply the forget operation, you have to use a conjunction and say that the left-hand side now equals to the right-hand side, because that's exactly what an assignment statement should do. So are we doing okay so far with these steps so far? Okay.
Could you explain that again? You said substitution is to find and replace, and then you said the last step was what it's being replaced with. I didn't catch what you meant.
Okay, the substitution has three components. The first component is pre-n, which is the precondition of line n. That's where what we are starting out with.
Right.
The second component is LHS here, which is representing the variable on the left-hand side of the assignment statement. That's what you're searching for in pre-n. And then the last component is f prime applied to LHS, which is the inverse function applied to the variable on the left-hand side. That's our replacement.
Okay.
So you have the original, what you're searching for, and what you're replacing it with. Question? Okay. All right. And then on last Tuesday, we went through a few examples. Okay, so let me kind of fast forward with this one here. And stop right there. Okay, so this is the concrete example that we went through on last Thursday. And instead of just referring to line N, LHS, and RHS, I give you a concrete example. In this case, the line number is line 67, so line 67 goes here as the precondition. This is given to you. In other words, this is something that I derived because of the other 66 lines before this line. So in step one, all we are doing is to identify what is the variable on the left-hand side. It goes inside the parentheses when we define the function. And what is the expression on the right-hand side, which becomes the actual definition of the function itself. Yep.
Do we have to write step 1 and step 2?
No, you don't have to. You don't have to use step 1, step 2, step 3a, and then step 3a1. But you do have to contain all the information of each individual step. You don't even have to say define. You can just say f of y equals blah blah blah. You can just say, okay, that's what it is. Okay. All right. So in this case, we do have f of y defined to be 2y because of the way the assignment statement is stated. And then in step 2, we look at the function f and say if f of y is just 2y, can we find an inverse function? In this case, well, yeah, if you double something, we sure can undo it by just dividing it by 2. So in this case, the inverse function exists, and we use f prime to denote the inverse function because we don't have the necessary tool to say to the superscript of -1. So f prime of y in this case is the inverse function relative to f, and it is just y divided by 2. This step here is extra. In other words, you do not have to prove to me that f prime is the inverse function of f by showing me all the steps and say if I apply f prime to f to y, then I get y back. Okay, so there's no need to show me those steps. I still recommend that you do it to convince yourself that that really is the case, so that you don't accidentally choose something that is incorrect and then ended up getting points deducted. Any questions up to this step, up to step 2? Now in this case, because an inverse function does exist in 3a, we just conclude and say use the substitution operation. Yep.
I know this doesn't really matter because you just said you don't really have to do all these steps, but when you have the inverse f to the -1 times 2y, and then that equals 2y divided by 2, how did you get that?
How do I get that?
2y divided by...
Okay, first of all, f of y is 2y by the definition of step 1. F prime of y is y divided by 2. In other words, f prime of whatever inside the parentheses is whatever inside the parentheses but divided by 2, and that's why f prime of 2y becomes 2y, which is whatever is inside the parentheses divided by 2.
Okay, perfect.
So I'm just expanding what is f prime in that case. All right.
That clears things up for me.
All right. Excellent.
Okay.
Yep.
Yoshi.
All right. And I have a new row sheet today. It's all fresh.
9 o'clock.
Sorry?
9 o'clock one.
Oh, yep, that's the 9 o'clock one. Go. All right, so now that we know there's an inverse function, 3a is just saying, okay, now that we have an inverse function, we apply the substitution operation instead of the forget operation. And then 3a1 has 3 steps on its own. So if you want to, you can say 3a, 1a, 3a, 1b, and so on. There's no need to give me the exact step numbers. This is not a legal document, right? But what you do have to do is to show me these 3 lines. The first line is important because the first line is the template of how to apply the substitution rule or the substitution operation. It is also important not just to know the mechanical aspect of how to perform the substitution operation, but also to understand why we use the substitution operation. When the expression on the right-hand side of an assignment statement is reversible, we have an advantage. Because according to the precondition here, before line 67 executes, or immediately before it executes, we already know something about y and how it relates to the other variables. In fact, we can say that we know that y is greater than 7 times z, and y does not have the same value of x. Okay, that's useful information because I want to use this to derive all the way to the end, the post condition of the entire thing.
How did you know that?
That's because of the earlier 66 lines, so I'm not.
Okay.
Yeah, so it's a given in this case. But in your homework assignment, you're only given with pre1 equals to true, so you have to start with that. Okay. So back to this case here, we know that immediately before line 67 executes, y is greater than 7z, and y is not x. That's something that we already know. Now the next question is, what do we know about line 67? What does line 67 do to y? Well, according to this, it is doubling the value of y. Great. The next question now is, what can we say after line 67 executes? In other words, knowing what happens before, can we make a conclusion of what happens after? And, well, can we? Well, yeah, we can. Sorry, go ahead.
It's still not equal to x, and it's double what it was.
That is not necessarily the case. What if y equals 2x before?
Oh, okay.
So we cannot make that conclusion. We cannot say that y does not equal to x. But if I have a way to reverse y back to its original value, then I can still say that original value does not equal to x. But how do I do that reverse?
Use the inverse function.
The inverse function applied to the value of y after line 67. So that's why we use a substitution operation, because what we are saying here is if I use this expression here, which is y, which is the inverse function applied to y, and use it to replace every occurrence of y, which refers to the value of y after line 67, then I can reverse it back to the value of y before line 67. So whatever I knew about how y relates to everybody else before line 67, I can now reestablish all of those relationships. So I'm losing nothing, because of the statement. Is that okay? Okay. Any questions? All right. If there are no questions, this is really an important part because I want you guys to understand why the substitution operation, works in this case.
And going from say line 67 to line 68, the post becomes the pre-68?
Yes.
Okay.
Yeah, I think I have an example later on that shows you how to relate the post condition of one statement to the precondition of the one that has to follow it. Yep. Because they're sequential. But just because two lines have consecutive line numbers does not mean they are necessarily sequential. So we'll go ahead and take a look at that again. All right, so from line 1 to line 2 of step 3A1, I'm just expanding everything that I know already. Because I already know that pre-67 is just if 7 is greater than 7z and y does not equal to x. So I'm just I'm just expanding pre-67 in that case. I also know f prime of y is just y divided by 2. I expand that as well. So from the first line to the second line is just expanding what I already know, and so that I can actually work on the substitution operation. From the second line to the third line is the result of the substitution. I go through this entire expression here and say, well, you know what? Whenever I find an occurrence of y, I will replace it with y divided by 2. This is my first find. Okay, it gets replaced by y divided by 2. This is my second find. It is also going to be replaced by y divided by 2, and that's the result of the whole thing. You do not need to perform any simplification if you do not want. There's no need to do it. So are there any questions about what we have done so far with steps 1, 2, 3A, 3A1, and then the 3 sub-steps in 3A1? So those are the things that you have to show me in your answer for your homework assignment. Some of you may have done it already, turn it in, and then, oh, I didn't know I have to do all these steps. Just download the document back, okay? Because when you go back to the homework assignment, you will see a link to the document that you turned in already. You click on that, download the document back, and just patch it up with all these extra steps shown. The next one, example 2, illustrates how to use the forget rule. So I'll go over that as well. And I'm gonna skip until I see the whole thing. Yep, that's it. That's the entire thing. Okay, so when you look at line 12, in this case, we also, once again, we identify what is the function f. In this case, the function f is defined as f of z equals to 5. We use z because z is the variable on the left-hand side, and then 5 is the expression on the right-hand side, and that's how we define function f. In other words, step 1 is really nothing more than trying to identify how are we defining function f. And I'd like to use function f because then we can just refer to the function and say, do we have an inverse? If it does have an inverse, what is it? Instead of referring to the expression on line blah 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 the whole time. Step 2, in this case, there is no inverse function because the right-hand side, the expression on the right-hand side of the assignment statement does not refer to the variable on the left-hand side, and that pretty much tells you that there's no inverse function because the value that you're mapping z to has nothing to do with z itself, and that tells you there's nothing you can do to reverse the steps back to find out what was the value of z before the operation. Is that part okay? Why it has no inverse function? Okay. Now, if it has no inverse function, according to the rule that we just talked about, you have to apply 3b. Now, this is a oversimplification. There are cases where you don't need to do a forget operation because there are other things in the precondition that can still tell you something that you don't have to forget. But in this case, I'm just going to make it very simple, and we'll just forget everything that we knew about variable z in this case. So in 3b, we explain why we use the forget operation. It is because there is no inverse function. So in 3b, we just explain why we use the forget operation. In 3b1, once again, we go through the 3 steps in order to get to the final result here. The first line is nothing more than a template. The template line says the post condition of line 12 is the result of the forget operation and z equals 5. Now, why can't we state z equals 5 outside of the forget operation? Because it occurs after the assignment operation. Okay? The effect of the assignment statement is z becomes 5. So that's why z equals 5 is a known fact after line 12 in this case. The forget operation itself refers to pre-12. So on the second line, we expand what is pre-12. In this case, pre-12 is assumed to be z is greater than x and x is less than y. So on the second line, I just expand that inside the forget operation. On the third line, I actually carry out the forget operation. Any expression, any comparison that involves the variable that I'm supposed to locate, which is z in this case, I'm going to get rid of the entire comparison. So in this case, z is greater than x involves z, and z is the variable that is in question right here. So I get rid of this entire expression on comparison, z is greater than x. So that means this operator also has to go away because the one of the operands one of the things it's supposed to operate on is now gone. So now I'm only left with x is less than y from the forget operation, but since z equals 5 is outside of the forget operation, it stays, and as a result, the conclusion is x is less than y and z equals 5. Are there any questions about these steps of applying the forget operation? No questions? Once you get the hang of it, you can probably just do copy and paste and change only a few things, and so it's not, it's not as time consuming as some people might think. Question?
Wait, so why do you get rid of z is greater than x?
Because z is okay. That's a good question. Okay, this is what we knew about how z relate to everybody else before line 12 executes. Z was greater than x, and we also know that x is less than y. Okay? The effect of line 12 is changing the value of z from whatever it was to 5. Is that okay? But that change can invalidate z is greater than x. In other words, it is possible that x was 0, z was
2. So greater than 2.
No, I have to change it so that x is 6. Okay, x used to be x is 6, z is 7. Then it will work out, right? Because once I change z is 5, change z to 5, then z is greater than x is no longer valid. So anything that may not be valid anymore, I have to remove. So that's why the forget operation needs to take place. Is that explaining what? Okay.
Could you explain how we go from the bottom, the second to the last line to the last line?
This one?
Yeah.
How we get from this line to the last one?
I think you just explained it very like you said, yeah, like why you removed z is greater than x.
Nothing is greater.
Like a lot of like how we know to do that, I guess.
You just remove the comparison. Any comparison inside this expression here that involves the variable that I'm supposed to forget, you have to remove the entire comparison. But once you remove the comparison, the operator next to it also has to go away because the conjunction doesn't have anything to do with anymore on one side.
There's no real place. Nothing is greater than x.
Right.
Doesn't really fit.
Well, I cannot say anything about z versus x anymore. That relationship is now invalid, maybe invalid. Okay, great. All right, so that's how you apply the forget rule, and then later on I have another example to illustrate the connection between two statements. So let me just kind of fast forward to that part. Okay, this is what we need to stop. Okay, I don't need to go through the entire thing, but I do have to go through this part here. Oh, stop. Okay. So what I'm going to do is to focus on only this part here. Pre-2 equals post-1 because lines 1 and 2 are sequential. This is how you can relate the post condition of one line to the precondition of the line that is immediately following the first line. Okay, but it seems obvious, but it's not always the case, and that's why you kind of have to state it too. Because if you have a conditional statement, so let's say this is n, line n is if c, then blah blah blah, and then line n plus 1 is let's say a statement. Okay, I'm just running statement 1. In this case, you cannot say the post condition of line n becomes the precondition of line n plus 1 because it is not always the case that line n plus 1 follows line n. It's a conditional statement. You have two ways to proceed. So it is not always the case that line n plus 1 will follow line n. And as a result, the argument of using lines 1 and 2 are sequential does not apply in this case. When you have a loop, it's the same thing. When you have a while loop and then the statement after the while, that also is the same argument.
So generally, if there's no control structure, then it's going to be
correct. Yes.
that. So it's going to be pre-2 equals post-1.
Correct. Now, it even applies when you're at the end of a control structure, and then the next one is at the same indentation level. Then you can still use that to link the precondition of the you can link the post condition of the line before to the precondition of the line after.
In the nested statements.
Right. Well, not necessarily So let's say we have blah, 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 blah. I don't even care what the conditional statement is here. So let's say this is my line 46. Okay. And in line 47 is something also complicated. It's a while, da, da, da. Okay. But how do we link the post condition of line 46, which is the conclusion of what do we know after the conditional statement executes, to the precondition of line 47, which is what we know right before the pre-checking loop happens. That still applies, because when you look at the indentation level, they still line up. So as far as we are concerned, at this level, these two compound huge statements are sequential to each other. So that's why in this particular case, we can still say the precondition of line 47 is the post condition of line 46 because they are sequential. Is that making any sense? Okay. So even when they're compound and not just simple assignment statements, you can still use this argument as long as they are truly sequential, right next to each other.
So it's fine to just put that on our homework instead of writing it out like that? Pre2 equals post 1, and then exclude the because lines 1 and 2 are sequential, or should we put all that?
I would put because lines 1 and 2 are sequential.
Okay.
Because you're using a word processor, so it's relatively quick to express that. In the exam, I'm thinking, but since I have to watch my own notes again, in order to remember to do it, I might give you some shorthands, like okay, this is statement A. It says blah 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 blah. So you can just quote, okay, I'm referring to statement A here. It applies here. So that way you don't have to spell out everything. Okay, that should be all that you need for your homework assignment. Are there any questions regarding your homework assignment? Questions? All right. Go ahead.
I'm just a little bit, I know that on the homework assignment you have the precondition to line 1 is just true. I'm a little bit confused about how we carry that through the process.
All right, that's a very good question. Okay, so let's think about the substitution operation first, okay? All right, so I'm not going to use exactly that example, but I'll use something that is close enough. Okay, so let's say this is my substitution operation. A is less than B and B equals to 20. I'm looking for X. I'm replacing X with X minus 1. Okay. So in this case, what am I going to do? Now remember, this is the same thing as a search and replace in a word processor. This is my original document. I'm looking for X, and if I do find X, I will replace it with X minus 1 in parentheses. So if I apply that search and replace operation on this expression here, which is A is less than B and B equals to 20, what would happen to the original document? Nothing, exactly. So that would answer your question as well. And the same thing here, okay, if I change this to a forget operation, if I say this is forget, A is less than B and B equals to 20, and anything in here that mentions X, I want to remove. Okay, so what would the outcome of the forget operation? Same as before, right? I'm not actually doing anything because the original expression does not mention X at all, so I get to keep the entire thing. Right? That's a good question. Any other questions? Yep.
So the precondition would be X equals true, because, right?
Say again?
The precondition would be X equals true?
No.
No? I'm sorry. I'm confused.
No.
This is a different example.
I'm just this is an example. This is the precondition, and whatever the expression is doing something to X. So this is not even the entire thing. I'm just focusing on the forget operation itself, and say what if you're asked to forget something that mentions a particular variable, but the entire expression does not mention the variable at all, then there's nothing to forget. You have to keep the entire thing there.
It's more like line 1 up there.
Mm-hmm.
X gets K.
Right.
So X would equal to true in the precondition, or I forget where the true comes in.
It's just that whatever the statement was beforehand was not false, it was true. And so since it's
the precondition of line 1 is true means
it's just true. That's it.
The
We know that this will
precondition is
work.
true, not X is true.
Okay.
There's a difference.
Yeah, that confused me. Sorry.
There are cases where X is true because X is just a variable, and a variable can certainly store a Boolean value, which is true. But in this case, in your homework assignment, the precondition itself is true, which basically says we can get here, but I know nothing about the variables at that point.
I got it.
Okay, all right. Any other questions? No other questions? All right. So go ahead.
So when you first started all this, you used an example for the inverse. For say you get somebody else's program that you didn't work on, and you have to go backwards. Say that precondition is not true, but you don't know where the issue is, where the error is in that program.
Okay.
You can't assume automatically that those preconditions are true when you're going back through the program. How do you fix that? How do you know? How do you
Okay.
prove it?
So let me see if I understand your question by you giving you an example. Okay. So let's go ahead, and I'm gonna get out of YouTube here. And I still have not started to monetize my videos. I don't think I'm gonna get anything. Sorry?
Run ads.
Run ads. I don't think there's enough traffic to make any real difference.
Like 5 cents.
That's only if you guys click anything, right? I mean,
And everyone in these classes probably know how to use AdBlock. So everyone in these kind of classes know how to use AdBlock probably.
Yep. Unless I can specify, what advertisement to put on it, right? I mean,
You could stream live for $5 subscription.
pay-per-view.
Or you could just bring up the ads on the through the video itself.
Brought
that
to you
way
by
can't
Audible.
Really block it if it's actually content part of the video.
I need to. Then I have to line up advertisers. I don't even know whether Google would allow that or not.
They do.
They do?
See the advertisements during class too.
I'll be wearing T-shirts with all kinds of logos, right? I'll be walking around like a NASCAR. That would be a interesting day. As you might have noticed, most of my T-shirts have no logos or symbols whatsoever. The only thing would be my shoes. I mean, but that's New Balance putting the "and" on the shoe, and it's not easy to take it off.
Especially if you're not trying to ruin the shoe.
I can paint it over, I suppose. All right, so let me see if I can, answer that question that was asked a little bit earlier. Okay, so let's say, we are on line, 45, and we have, a statement here. It says, if x is less than y, and then on line 46, we say x gets x minus y. On line 47, we have an if. And then on line 40, okay, so that's it. Okay, so this is just a little part of a program that I'm trying to analyze. And I'll just say, at line 47, the post condition of line 47 is x equals to, let's say 5, and y equals to 50. Okay, yeah. And we'll just throw in something else, that has nothing to do with it. So we'll say, z is greater than y, and w equals 31. Okay. In other words, We know certain things about this program by the time we get to line 47. When line 47 is done, and this is where the program stopped. And I looked at the program. It's not supposed to get here, or by the time it gets here, these are not supposed to be the values. Okay. So now the question is, can I reverse this, these particular statements, lines 45, 46, and 47, and come up with a potential, a scenario of line 45? Can I use post 47 to derive pre-45? That's basically the question. Is that kind of?
That's it.
Okay. So can we do it? The answer is yes, we can actually do this. Okay. But to illustrate it, I think a picture would be more helpful. So we're going to draw a picture here. And having cameras on cell phones, also really kind of changed the whole landscape of, of taking notes. Because, when I was, in college, my professors, it's really the worst time ever to have, technology, to a certain stage, because that's the time when overhead projectors became reality, and professors really like, overhead projectors, especially those computer science professors who like to print everything, using the laser printer. But it's before, we have, cameras or inexpensive cameras that we can take to a class, and it's digital. Okay, so now what happens is, the professors would make photocopies of either their own notes or something else, and bring an entire big pile of these things. Or sometimes it comes in a roll. Okay, they would write everything in a roll with permanent ink, right? So when they talk about something, they would just be sitting here because they have to sit, at a certain place, and then they would just talk about it, and then they roll, and then the class would frantically try to copy, because the professor himself or herself doesn't have to write anything on the whiteboard or chalkboard. If that is the case, then it's okay. When the professor is writing, I will be copying, right? But if it's on a projection sheet, especially when it's densely populated with stuff, pictures and diagrams and whatnot, the professor would just go, now it is really kind of obvious that this step follows this step, and blah, 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 roll. And the whole class would be frantically trying to copy. It's like, no! Yeah. But now, at least you guys have digital cameras, right? On your phone, you just go, okay, we're done. So let's take a look at at this particular example. Okay, first thing you do is you draw a picture. It really, really helps when you draw a picture, because the else branch is implicit in this case. So you want to draw the picture to make the else branch not so implicit anymore. Okay. What we have concluded here is the post condition is x equals 5 and y equals 50, and z is greater than y, and w equals 31. That's the conclusion here. Now, but when I'm standing here, I could have come here from either path. And at this point, I cannot rule out a particular path. So what I need to do is to say, well, maybe I came from this part, or maybe I came from this part. Now, but that is important, because if I came from this part, it means, this condition here, which is represented by post 46, can be the same as the entire post condition. So getting back to my projector here, whenever possible, I'm going to use the projector. So post 46 is the same thing. It's possible. Or at least at this point, I cannot rule it out. Okay, so we just stash this entire thing here. But the alternative path is even more interesting, because it is also possible that I came here directly from the else case of x is less than y. Actually, that does not work out in this case. It's not what I intended. So if you have copied it, just change it to greater than or equal to. Okay. So I could have come here from the else branch of 45, line 45 as well. But would that be consistent with line 45? In other words, is it possible for me to take the false branch, given the condition is x is greater than or equal to y? Could I have taken the false branch and end up here with the conclusion of post 47? Is x not greater than or equal to y? That's the question. It's not, which means it is possible. Okay, so this is also a possible condition up here. Okay, great. But is it possible that I come from the the then branch of the conditional statement? Yep, that's entirely possible too. So if I came from the then branch, that means now I should be able to reverse the operation to get back to pre-46. The question now is, can I reverse this operation? I'm not going to go use the 4 steps here. If I know that after I subtract 50 from x, x ends up with a value of 5, what would be the value of x before I do the subtraction? 55, right? So I can infer and say x equals to 55 and y equals to 50, and the rest, because z has nothing to do with this assignment statement and w has nothing to do with this assignment statement. Now the question now is, can I attach the condition of the conditional statement here as well? Because line 46 is the first line of the then branch, and at that time the condition of the conditional statement should be true, because otherwise I would not be executing line 46. Is it consistent with x is greater than or equal to y? It is. Okay, so that tells me one really kind of important thing, because it tells me that the precondition of line 45 is not really quite as simple as we think it should be, because we know a whole bunch of stuff has to be true. Y equals to 50 has to be true, because nothing here is modifying y anyway. Z is greater than y, not a problem. W equals 31, not a problem. But one thing that we may not be sure is whether x equals to 55 or x equals to 5 prior to line 45. It could be 55, so that we go through the then branch. It could be 5, so that we just skip the then branch and go all the way to line 47 right away. So is that kind of answering your question? Yeah. But as you go back, you can see that every time you go through a conditional statement, there are more possibilities coming up, and then more and more. So at some point, the expression becomes really long and complicated, which gives you all the possible scenarios to get to a particular point in your program. And at that point, if you have control over the program, if you can throw test cases at the program, then you can help rule out how I got here. Because you can now say, oh, okay, x can be 55 or x can be 5, but if you can inject a particular value to force it go through either way, then you can say more with more certainty how you get to this point. It's not going to be easy going backwards line by line, but the thought process of thinking about this way is what you need when you're debugging a program. Yep.
For the homework, we have to show the inverse though, right? It's not just the pre-impose.
For your homework assignment, you have to show the inverse too. In other words, you have to tell me whether there is an inverse or not. If there isn't, obviously there's no inverse to talk about. But if there is, you have to show me what the inverse is. But you don't have to prove that the inverse function is in fact the inverse function. Okay. So are there any questions about the pre and post conditions? No questions? All right.
I just have one
Go
last
ahead.
question. On the pre and post conditions for the homework, you explained to me earlier when I asked you, it says substitution and then each value. You said there's 3 steps for the substitution.
There are 3 components to the substitution operation, but there are also 3 steps to it.
Can you type that down so I can write it down? Just so I cannot remember for the life of me.
Let me check one thing first. Okay, it is getting recorded. So that means, when you watch YouTube, everything that I did on the projector is already recorded.
Okay.
Yep. I don't want to kind of, just say that, okay, we'll do this after class, but it is recorded, so you can actually refer to that also. So I'm feeling great, having all my, recording from my previous lectures, because now I have a recorded lecture that refers to an earlier recorded lecture. And then on next Tuesday, when I explain the answer of the homework assignment, I might bring up this video recording or the video recording of this class too. So we'll be
YouTube
watching
Inception.
a recording of a lecture. Well, talking about nesting, right? I mean,
Nesting videos.
Nesting videos. Yep, exactly.
It's a video which you do a video.
But every time you do a nested video, the quality of the video is supposed to degrade because it's a lossy compression. So we'll see how many times we have to go through this, so that the text is actually not legible anymore.
I saw a video. It's like 900.
Say again?
It's like 900 times.
900 times?
Before it's like
If you do good
you
quality.
sound like.
Yeah, this is actually pretty good quality to begin with. I mean, but still, it is still lossy compression. Yep. All right. So let's go ahead and go back to our usual track. This class is a little bit ahead of the other class. It's not always a good thing. Sometimes it means we're skipping things a little bit too quickly. But we are now moving on to topic 4. Unless you guys have questions about the previous topics, we are now moving on to topic 4. And let me turn the highlight on to topic 4 so we know this is our current topic. Topic 4 talks about top-down design. We talk about the reasons and the techniques of using top-down design. And also, there's one example in here too. And you can see there are practice exams here as well. Because it depends on the semester. Sometimes I can get to top-down design by the time I get to the first exam, and this year or this semester, I was not able to get to this point. Okay, but this is the actual note of top-down design. We'll take a quick look at this. Okay, the first thing we need to know is why are we using top-down design in real life, not just in programming, but in also many of the other things that we do. Let me just do a quick survey here. How many people have taken English 1A or whatever is equivalent to the college writing class? Okay, and what is the length of the paper that you have to write as your final project or final paper? Using the typical 12-point font and double spacing. 10 pages or so. Okay, 10 pages is not too bad. I wouldn't say it's a really long paper, but depending on what your professor requires of the structure and stuff like that, you still have to spend some time to do it. How many people can write that kind of paper from page 1 all the way down to page 10 without having to go back and change things or just keep writing, right? I mean, I'm gonna sit down, I have 4 hours on my hand, I'm gonna use this block of time and write that paper out in one single shot.
No guarantee it'll be perfect.
Doesn't mean it's any good. But
Yeah.
Oh,
I can do
okay,
that.
well that's a good qualification right
You
there.
don't have to.
But what is the problem? Why is it difficult to sit down and just write a 10-page paper without planning or structuring all of that stuff?
Many parts to it.
Say again?
Many parts to it.
There are many parts to it. But let's just say that you did your research beforehand and you know the subject matter really well
You can start repeating yourself.
and not realize, right?
Yeah.
Okay, or you can be missing certain things that you meant to mention, or you can basically lose track of your own, argument or your logic, when you're writing that paper. So all of that stuff can happen when you're writing a paper. Another example of why top-down design is important. Okay, so if that is not the proper way to write your 10-page English paper, how do you get started with your 10-page English paper? An outline, okay? And how many items do you put into your initial outline? I'll give you like a few numbers. 5, 50, or 500. 5 is a good number. Okay, why is 5 a good number for most people? It's basically how many things we can track in short-term memory. Okay, some people can track a lot more. If you watch the movie Rain Man, okay, Dustin Hoffman, or the character that he played, was able to track a lot of things. I think there was one scene where somebody dropped either toothpicks or a stack of cards, and he was able to tell the number of things that was on the floor. And of course, they took him to the casino because he can count, right? He can remember, what cards have been played already. So he was able to, win some money that way. Okay, but for the rest of us, okay, 5 to 7 is, what they say is, all the concurrent things we can track is about only 5 to 7. All right. Well, that's one example. If you want a really graphical example, we can do it like this. We can go to maps.google.com, and then we'll go ahead and zoom out. This is our world map here, more or less. All right. Where's ARC?
There.
Well, you guys kind of know where it is supposed to be at. And we cannot see ARC because we're zoomed out too far. Okay, so maybe it's a limitation of the projector's resolution. So if you, hypothetically speaking, if I give you a projector with infinite resolution, then I can actually display all the details. Would you be able to find a particular place if you're not familiar with that place to begin with? For instance, if I ask you to find where is Winston Churchill Middle School, would you be able to find it?
Eventually.
Eventually, okay, very good. But what is the problem?
Don't know where it is.
Well, what if I tell you it's in Sacramento? It is, a little bit to the south of ARC.
Well, that's a lot easier.
But using this map though.
Oh dear.
With infinite resolution and a magnifying glass.
Find ARC first and then go.
Right, you have to find ARC first, but then this is the map that I am displaying. Remember, it has infinite resolution, and I'll give you an infinite magnification, microscope also. So in terms of optical quality, there's no issue here. Okay, you could have a monitor that has infinite resolution, and I give you a magnifying glass that has infinite magnification.
Still
It will still be difficult. It will still be very difficult because you have so many details, at one single place. So it's difficult to locate things because you can't even easily distinguish one thing from the next thing. Okay. Most of you are way too young to remember the maps from AAA. Okay. These days, when you go someplace that you have never been before, you just whip out your phone and talk to your phone, right? Navigate to da 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 da, and then your phone will talk back to you and say, take the next right turn, da 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 da. You just have to. You don't even have to look at your phone. You should keep your phone somewhere else in your car. What do we do? How do we do things in the good old days when you were like 2? Your parents are driving to a new place.
Pull out the map.
But you need a lot of planning first, right? Okay. Before the trip, we have to pay a little visit to AAA for those of you, with parents with AAA membership because they give out free maps. Okay. So now you have like a whole stack of maps because you need to have maps from wherever you are to the destination and everywhere in between, because you just want to make sure that you will be able to find like a Chevron or a place to eat or whatever in between. Okay, so let's say I'm giving you a map of Sacramento, and how many maps do we have for just Sacramento?
Few.
Well, if you go to AAA, I think there are 3 maps for the Sacramento County, the Sacramento area. Okay, and I'll give you a street name, okay, that you're not 100% familiar with. What do you do with that street name? You flip the back of the map. You look up an index, and it will give you a square, right?
Yeah.
Now you would think that would pretty much shorten the search time to almost nothing, right? I mean, you give you a square about this big.
Now you gotta find
But
the
how
square.
many street names can you fit in the square like this when you're in, let's say, downtown Sacramento doesn't count because it's all in a logical order.
It's on a grid.
It's on a grid. So let's say Autumn Park, which is really one of the worst place to find a place because it's the streets all kind of curve in a strange way. They disconnect and then they connect again, and and they don't. There's no specific order, right? How many streets do you think fit into one little square? Quite a few. Okay, more than 7 for sure. Okay, so that's another reason why we use top-down design is because we cannot track all that much detail at the same time. So if I tell you that ARC is in California and California is in the United States, then you know, oh, okay, we just need to zoom in this part here. The rest of the states do not matter to me because I just need California. And in California, if I tell you that ARC is in Sacramento, now you can just kind of zoom in to Sacramento, and you can see that every time I zoom in, the number of items that are displayed on the screen is still limited to about, I would guesstimate it's between 20 to 30 at the most, okay? But not like insanely, many, like 300 or something like that. So now I can zoom into Sacramento. And I can then tell you that it is somewhere between the two highways. Okay. And then you get the idea. I mean, we can zoom in, search a little bit, zoom in some more, and that's how we do things. We are pretty much there. I mean, this is Cottage Way, that's Watt Avenue, and ARC is
Keep going.
up there somewhere, right here. So we can zoom in, and now, well, now it actually has, now it has, the building names. We are in liberal arts. This is 121.
It has a little
When you switch to satellite, it's an actual picture.
Yep. It's a satellite picture, and we are pretty much right here.
Can we check out Ukraine?
Can we check out what?
Ukraine.
Yeah, but
Ukraine.
you were able to make it out, like
Just the border where Poland is.
Blacked out.
Poland.
Well, because of the recent events.
Yeah.
Maybe Google has
They sent some Google cars down there for a good street view.
I think Google should start to operate drones. Yeah, Google drones. And then we can collectively pay and have a drone to fly at a certain place. That would be kind of cool. Yep. Yeah.
What do you think the resolution on those cameras are that they have on the satellites?
The resolution of cameras on.
That they have on the satellites, they're taking these pictures.
Well, these are not satellite pictures. What they call it satellite is actually aerial. So they're actually taken by airplanes. So they have planes to sweep. And I would not be surprised if Google, automate, those planes too, or they're already automated. It's actually easier to automate airplane compared to cars.
What stuff to hit.
Yeah, there are no pedestrians. Let's just say, and you have ways to turn. You don't. There are no streets. And, there are less requirements, less restrictions. Okay, well, that's another example of why top-down design is important. And the last one I'm going to give you is something that we talked about already in this class. I give you a 4 terabyte hard drive for free, but the only restriction is you cannot have subfolders. Yep, you guys remember that one too, right? So we can store a lot of files. I mean, even if you use the raw file of these new digital cameras, the new digital cameras have about 20 megapixels. If you use a raw format, you can store each picture. Let's say it's about 25 megabytes
For 12 megapixels.
or 12. So if you double it, it becomes 50 megabytes. It's still nothing, right? I mean, how many pictures can you store, each one taking up 50 megabytes in a 4 terabyte hard drive? Well, let's do a quick math here, okay? Because you guys should be able to do the guesstimate really, really fast. So we're talking about 4 terabytes, and we're dividing it by 50 megabytes, okay? Okay, so how do you do this quick math really quick? Well, you look at 4 terabyte as 4 times 10 to the power of what?
6.
No, 6 is only mega, 9 is giga, 12 is tera. Okay? And then we have, right? Yeah. And then down here we have 5 or 50 times 10 to the power of 6, because that's a million. So you move that 0 over here, it becomes 7. And you divide, when you divide power, you're just doing a subtraction. So 7, 12, this becomes 5. So you're talking about 4 over 5, which is about 1, times 10 to the power of 5. So that's about 100,000. Okay, 100,000 picture on a single hard drive, and those are in raw format, which is pretty much as big as they can possibly be already. Can you organize and find a picture within 100,000?
If you name them all.
Yeah, if you name them all.
And they're all named as IMG dash and then a bunch of numbers, right?
If you memorize the numbers. Outside of that.
Those are folders. That's the whole point. Is we don't
If you
use
memorize the
top-down
date,
design.
too.
We just have
Still
one
organized by date.
single flat level of stuff.
Yeah.
Where you should find time taken and guesstimate when you took that picture.
You can still guesstimate, based on time, but it would not be easy. It would not be easy. Yep.
You can just put like a little blank file in the thing. It's like the date and when you took it for pictures.
Well, what would actually be helpful is actually Google. Does anyone do you guys have anyone played with a Google Goggles, the app called Goggles? Okay, and you can tell the rest of the class what it does, or one of the things that it can do.
You
Google
take a
Goggles?
picture of something and then it matches it with images online, or it can read barcodes.
Yep, it can read barcode, it can read text, okay? It can even recognize architectural stuff. If you take a picture of like a monument of some kind, Google Goggles would come back and say, oh, this is blah. It actually can do recognition. If I remember correctly, Picasa, which is also a service offered by Google, you can train it and say, and give it like 10 pictures of grandma, okay? And you can say, this is grandma, this is another picture of grandma, this is another picture of grandma. And you can train the engine, to recognize grandma. And then after that, you can upload, all your family reunion pictures, and you can type search, and you can say, I want all the pictures with grandma.
That's cool.
And then go like, okay, here's one, here's another one, and so on. In other words, with that type of search engine, even with a hard drive with that restriction, you may still be able to find something relatively quickly. But in a certain way, it is also really creepy too, because in order to take attendance, I don't need the sign-up sheet anymore. I just need to take a picture of the entire class, run it through Google, and it comes up with a list of people in the picture, and I'm done taking roll. Every time you walk into a store with a security camera, they can tell who you are. They can say, oh, you're a customer, blah, blah, blah. Last time you came in here and you bought this item and that item. May we suggest that you also take a look at this aisle and this item over here.
Pretty similar.
Most people who bought these items that you bought last week also bought this item. It's gonna happen. It's going to happen. Your shopping cart is going to have a little flat panel screen, and it will help direct you to things that might interest you.
You can plug it or scan it.
If it's not already done, you should make it happen, and it'll be worth a lot of money to supermarkets. Yeah.
Like, well, they would have to keep the shopping carts inside so they don't get stolen.
Watch out for homeless people.
Yeah.
But the same device can also be your tracking device now, right? I mean,
Yeah.
it actually improves security
Yeah.
instead of
Hire people to go
having it
find
as a
out.
liability, because now that thing can actually beep you and alert security as it is on its way out of the parking lot.
Yeah, just a very loud and obnoxious beep beep.
Shock.
Or they-
Electrical shock is like. But all of that stuff is going to happen. We might be laughing at this and go like, yeah, it's going to happen. It's going to happen. If I can think of it, I'm pretty sure hundreds of people have thought of that already, and even more people are working on it. Because they want to sell you stuff. So if they know your pattern, they're gonna sell you more stuff. But they don't want you to kind of enter your personal ID and stuff like that. So by doing the facial recognition, that's one quick and easy way. I mean, the technology is there already. Why not? Yep.
I think a lot of it's over there, but even your smartphone, like I just got the new Note 3, and I had it 2 weeks, and it already said going to work, and it had ARC, and I'm like, how the hell did it know that would be just
Because
going
it has been
today?
tracking, when you are going where, and and it knows your pattern as well. Yep, it's definitely getting that. Yep.
I like how that can tell you, like I had a doctor's appointment or a DMV appointment, and they sent me an email confirmation, and then Google Now told me like, hey, there's traffic, you're gonna have to leave 10 minutes earlier. Just give me a notification that day.
Yep.
I think it's really cool.
It's kind of cool and creepy at the same time.
Exactly.
Looking
It
at
is.
your stuff.
It's cool and creepy at the same time. That's a good description of where we're heading. Google Glass. Okay, Google Glass. I think there was an incident maybe a week ago. A woman in San Francisco. In a bar. She was wearing one. And then she was in a conversation. It was, an argument with another person in the bar. And the other person said, I don't want you to be recording here. And then essentially, this person who was wearing Google Glass basically said, "Guess what? This part is also getting recorded." Yep. And it's going to happen. So when you have, when Google has access to all of these images, from Google Glass, your cell phone, through, Google goggles and all of these other things, just think about what it can do in terms of figuring out, where you are at any particular time of the day. Because it's not just your camera. It is also the camera of everybody else that can have your picture in it. And as a result, these engines can now say, okay, this person is at this place or at this place or at this place. It can be a good thing if you need, to establish your presence, not to be at a crime scene in case, that comes up, okay? But in the case of a criminal, it is also the worst enemy because now, there's no way to evade the camera because everybody has one, and that person is on the camera of just about everybody. In some countries, not in the United States, but in some countries, they have a in-car camera in every single car for insurance purposes. Okay, so we are talking about, every single car has a camera that looks out and record everything, at least within a day or two. Okay, and that would include, the picture of the other drivers' license plate of other vehicles, pedestrians who are crossing the street, everything. So just imagine, once we have the processing power to kind of, process all those, images, just think about what kind of information the organization has, whatever organization has access to the videos and the images, that organization now has a lot of information.
Those cameras record outside the car?
Yeah.
Okay.
Yeah, they record outside of the car. I would not be surprised if they have another one that records inside, just so that they know the reaction of the person in case of an accident.
I thought it was like to make sure they aren't on their phone while they're driving or something.
That might be the case too. So they might have one pointing in and one pointing out.
On the news this morning, they're reporting that Sacramento cops are going to have cop cars, cameras facing each direction outside of the cop car, and microphones to. I don't know what the
I don't
radio
think it was the Sacramento PD. I think it was a different PD.
It could be CHP. That can be CHP. CHP has recently changed all the vehicles to basically Explorers. So I would not be surprised if they, also change the electronics, in those cars. So CHPs will also double as Google Street View cars.
Eventually they'll get a real estate thing going up, and they could give reports about what goes on in the neighborhood. You don't want to live here. There's a lot of bad activity.
They drive by themselves.
Sorry?
You mean they drive by themselves?
I think police cars, can be a candidate of, driving by themselves because that really makes patrols, a lot easier because the person you will still have policemen inside the vehicle, but they can stay, just being alert, but they don't have to waste a lot of energy just driving the vehicle.
It seems like most of them are on their little computers in their car nowadays, anyways.
Oh yeah, they have all kinds of stuff in their car. I mean, they can now pay more attention to the radar, the speed gun and stuff like that. All right, but I digressed. Just a little bit, just a wee bit. But getting back to top-down design, those are the reasons why we use top-down design, because it has to do with how many things we can track at any particular point. But in programming, we also have a particular limitation. Because in programming, whether it's pseudocode or actual code or whatnot, we have a physical limitation of how many lines you can fit on a particular screen. Okay? That's a limitation. It's a hard limitation. I know we can buy really high resolution screens now. What are they called? The ones that are 2560 by, like
4K?
the 4K? Okay. Say again?
It's like 30, 40 by,
Okay, but even those has a limitation as to how many lines of code you can display at any particular point. So the thing is, if your program or if your pseudocode does not fit on one page, then you have to go page up, page down in order to look at different portions of the same algorithm. Does that make any sense? And that's not good, because if you have to go page up, page down in order to look at an entire program, that also means you can no longer easily track the beginning of a construct and the end of that same construct, because they may not belong to the same page anymore. Is that making any sense? Okay. And anytime you have an algorithm of that kind of complexity and difficult to read, it is also at the same time difficult to debug. Okay. In the old days, people had a fan-folded paper when they print out program listing. Do you guys know what is fan-folded paper?
It's like
dots on the side.
Yeah, it's perforated so you can actually tear it into individual pieces, and then the dots or the holes on the side, they are intended for the rollers of the printer, so they can basically roll it with high accuracy, so it won't shift and skew when you feed the paper into a printer. Okay, so in those days, okay, let me just look up fan-folded paper long programs. And that's a good picture. It's not a particularly long program, but it kind of shows you how people read program listing in the past. Not easy, okay? Not easy. And I have seen people look at their program. They have to lay it out on the floor. Okay, so they basically unfold the fan-folded paper, lay it out on the floor, and then they get a long ruler so that they can line up the indentation. And it's not surprising. In my previous job, back in I would say about 95 or so, I had to deal with a particular program where a single subroutine, or you can look at it as a single algorithm, had more than 500 lines. 500 lines. Most of these printers can print about 66 lines per page. So a 500-line algorithm will take only about 8 pages, which is not too bad. I mean, 8 pages, fan-folded, is about 8 feet long. Okay, because one page is about 11 inches long. So we're talking about only about 8 feet long of listing. And there are worse programs out there too.
by far.
Okay? But it's not easy to deal with it.
Back then, though, I mean, the programs weren't that huge, were they?
They were, well, but we don't have the programming tools or concepts that we have today. In other words, back in those days, we barely have structured programming. We did not have object-oriented programming. So there are a lot of mechanisms by which we can structure a program so it is more easily maintained were lacking back in those days. Especially when you program in assembly programming language, that there's no structure whatsoever. So it's up to the programmer to really impose any type of structure on the program itself. And when you have people working day and night, sometimes they don't think about those things.
Yeah.
Yeah. So starting next week, we'll be starting to talk about structured or top-down design, and we'll have one example in that chapter that talks about it. So you should read ahead of me and make sure you do the homework assignment and turn it in on Thursday. I'll see you guys on Thursday.
I have a question.
Yep.
From the old homework assignment. I